Good morning, good afternoon, good evening. It's your boy Mr. Malachi, and I'm back with another video. And in this video, we're going to be unpacking how do we go about solving inequalities. So inequalities are these equations that have greater than, less than, greater than or equal to. So this is called the greater than and equal to sign, and then this will obviously be less than and equal to signs. So what are these things? First of all, we've been solving equations, and by now you can solve an equation and you will end up with, let's take a linear equation where you end up with a singular value of x. So this one tells me that x is a definite singular value, which is 2. But with inequalities, x is greater than 2. So these are the solutions we'll be coming up with. And what does that mean? It means x could be any value that is above 2. So you can think about different types of numbers. Number one, you can think about integers. So what values greater than 2 are integers? It's a 3, it's a 4, it's a 5, it's a 6, and you can list these going, yeah, as far as you want. Then you can even think about real numbers that are greater than 2. That's going to be a 2.1. You can do as low decimals as you want, 2.02, and keep going. So instead of x being a singular definite value, x now is equal to a range of values, right? And what we do is we try and represent this on a number line. So let's jump right into how do we solve this. But before we go there, there's a golden rule that we need to remember when you're solving these. And this is the golden rule. When we're dividing or multiplying by a negative on both sides of an inequality, the sign needs to change. This changes the sign of the inequality. So there's a this that is missing there. That's the conclusion here, that if we're multiplying or dividing by a negative on both sides of an inequality, this changes the sign of the inequality. So what does that mean? It means if I have a greater than and I divide, let's take a case where it looks like this, and I'm dividing by a negative 3 on both sides, then the sign needs to change and it needs to point in this direction, where you have your negative 4 over 3 this way. So initially it looked like that, where the sign was saying greater than, but now as we read it, it's x is less than the negative value that we just got. So I hope that makes sense. Yeah, let's get right into the examples and see how do we apply this. All right, so before we start into solving these, let's at least differentiate that there are two different types. There's the first type where we have these normal inequalities. They only have one sign. You'll see there's only one inequality sign, right? And then these compound ones, you will notice that they have two inequality signs. So we have to be cognizant of that. These are the two signs, and the way we solve each of them is just slightly different. So let's get started on the normal ones. So how would I go about solving for x? So what you would do is I would try and isolate the x on one side, so that inequality sign works just like an equal to sign. When you take things over, just like an equal to sign, right? When you take things over, the same thing happens. The sign changes of that term. So 3x minus 9x is less than 4. And then 3x minus 9x gives me a negative 6x is less than 4. Then if I divide by negative 6 on both sides, then x, the sign also needs to change. Let me put it in red. it now points in that direction, and it's equal to this guy. So x is greater than negative 4 over 6. And for interest's sake, if we were to represent this on a number line, we would put negative 4 over 6 there, right? We would put a circle there, an open circle, right? I'll explain more about that, right? And then we would try and interpret this. So how do we read this? This is x is greater than this number here. So x is these values that are this side from the number, right? All the values that are greater than that number. So that's where they exist. So that's how you would draw it on a number line. Let's try example 2 of the normal ones. Or actually, let's move on to example 1 of the compound ones. How do we go about solving these? These, what you would do is you would treat each sign as an equal to sign, right? So if I'm taking a 1, it goes there, it changes sign, but it shouldn't just go to one side. It should also go to the right. So it gets to the right and it also changes sign there. Then you subtract those, you get a negative 6. And you subtract this, you get a positive 9. And if you divide by a negative 3 and a negative 3 and a negative 3, the golden rule says if you're dividing by a negative or timesing by a negative, the signs need to change. So I'm going to write the signs in black. They're now going to point in that direction. And if I divide, this is a 2, this is an x because they cancel, and this is a negative 3. So the way you read that is you read it in the perspective of x. X is less than 2 and x is greater than negative 3, right? And if we were to draw that on a number line, again, there's my number line. Just scroll a bit. We have our negative 3 here. Excuse me. And we have our positive 2 there. Then this would have a closed circle, and you're sitting there wondering, why is it closed, Mr. Malachi? Because this sign says greater than or equal to. So the fact that we have a slight dash there at the bottom, it means equal to. So it means one of the values includes the negative 3. So closing the circle, I'm saying negative 3 is included as part of those solutions. And where does it go? If you read it, x is greater than negative 3, so it goes this side. Sorry about that, number line is right on top of my answer, but it goes this side all the way to a closed circle going to 2. And how would you read it from the 2's perspective? You would read it that x is less than 2. You always read it from x and you look at what the sign looks from the x. And that's it. That's how you draw this, and that's how you draw this. And this is how you would solve a compound, and this is how you would solve a simple one. Let's take fraction ones of each and look at those. Alright, so on the left, we're given a fraction inequality there, and on the right, we're given a fraction inequality, but this is a compound one again. It has those 2 signs there. So how do we solve the one on the right? On the left, sorry. LCD, we need to find the LCD. Remember, that's how we work with fractions. We always find LCD. And what we do with that LCD, we times everything with the LCD. Luckily, our LCD is positive, so it's really not going to affect our sign. So you need to always be cognizant of what you're doing. Am I multiplying? Is it a positive or a negative? So in this case, it just cancels, leaving me with just a 2x minus 3. The 2 and the 3 are going to multiply, giving me a 6. And I'm going to come back and distribute into that bracket. I hope you're doing it like this. Then you distribute the 6, and the 6 times 1 will give you a 6. Then you would collect your like terms. So I'm bringing the 6 over the 6x, making it a negative. I'm bringing the negative 3 over, and it's going to become a positive when it gets there. And you subtract these, you get a negative 4x. You add these, you get a 9. You divide by negative 4, you divide by negative 4, and so the inequality reads x is less than. I hope you guys are seeing the sign change. Again, I'm dividing by a negative, so this should read less than or equal to, and what is the fraction? 9 over 4. So again, I like these questions because they're resulting in a fraction, right? And so that should condition you guys to see a fraction as a possible answer. There's nothing that we did wrong. We can check our math, but there's nothing that we did wrong. And so this is correct. And so what we need to do is just plot it. If this is my negative 9 over 4, if this is my closed circle, again, remember, equal to means closed. So the circle on your number line needs to be closed. And if you read it, they say x is less than. So x are all these values on this side of that value. All right, cool. Then let's do the second one. This is a compound. We need to find LCD as well. And in this case, our LCD is 2 times the 5 is a 10, times the 3 is a 30. So 30 is our LCD. So the 4 over 5 times the 30 this times a 30 over 1, and this also times a 30. Then you cross multiply. This goes there 6 times. 6 with that is 24. This and that is 15. So you get 15n plus 15 less than or equal to. And take note, these signs do not look the same. This one just says less than, but this one says less than or equal to. And if I keep going, this is 10, and so that is a 70. Then if you take your 15 over, remember it has to go on both sides, so it needs to also come to the right hand side. And if you subtract those, that gives me a 9. And if you subtract those, that gives me a 55. You divide by 15, you divide by 15. This is a positive 15 in this case, so I don't need to change the signs. If you simplify that, that is a 3 over 5 less than n, where n, sorry, I changed my sign. I just warned you guys about this, and I'm out here doing it. The sign here is just less than, it's not less than or equal to. All right, and this, if you divide by 5, it's 11 over 3. And there we go. That is our final answer. But if we were to draw this again, let's plot it on a number line. There's my number line. The 3 over 5 would obviously be this side, it's smaller. The 11 over 3 would be this side, it's bigger. Then this side would be an open circle because Look at it. It does not have the equals to sign. And if I read it, n is greater than it, so it's going this side. This side, I'd have a closed circle, and it arrives that side. And again, if you read it from this perspective, n is less than that number, so definitely the arrow is going to go this way. So n is actually all the values between these guys. This is a very interesting, but it does not include this value. But this side, yes, it does include this value. So I hope it makes sense, guys. On that note, I'll see you on the next video. Bye.